Given these two cubic functions, and we're told that f of x minus g of x is greater than 0 for every real x. So let's go ahead and calculate that, and I can just subtract them in pairs and factorize things out. So it must be that a minus p x cubed plus b minus q x squared plus c minus r x plus d minus s is greater than 0. And this is true for every real x, and then we're asked which of the following are necessarily true. Now, one thing we can do straight away is just to put in x equals 0, because we know this is true for all values. And then we would get d minus s greater than 0, so d is greater than s. Okay, so 3 must be true. What about a being greater than p? Now, the thing is, when x becomes large, this term is going to dominate. And if a minus p is greater than 0, you're going to get a cubic that's going to go to infinity here, but it's going to go to minus infinity here. So it's definitely going to go below the axis. So it can't be true, basically. And then if a minus p was less than 0, well, I'd get a negative cubic. And actually, for large values of x, it's going to go to minus infinity. Again, it would go below the axis. So the only thing that is possible is a is equal to p. Because then what we'll have for large values is that cubic term disappearing and the quadratic term is going to dominate. And actually, b minus q would have to be greater than 0, because then you'd get the quadratic going to positive infinity in both directions. So what I'm doing here is ruling out statement 1. It can't be that a is greater than p or a is less than p. It must be that a is equal to p. So now we know that I can actually just get rid of that. And then statement 2 says if b is equal to q, okay, just in that instance, then c must equal r. So in the instance, that will disappear. And then I'm left with this function here. So for large values of x, this is clearly going to dominate. It's going to be the same argument. If c minus r was greater than 0, then for large values of x, it's going to look like that. And for small values, it's going to look like that. It's again going to cross the axis. And then if c minus r is less than 0, it would look like this. So along the same lines of reasoning as before, yes, it must be if b is equal to q that c is equal to r, because that will cancel it out and then we'll definitely get something that's positive. Otherwise, at some point you are going to cross the axis and it will become negative. So that one is true. Our answer is therefore G.